Hi, in this video we will learn about probability. What is probability and why are we discussing it? Well, according to me, I say we live in midst of probabilities. We can't say anything for sure. There's barely anything that is definite. For example, if I say I will come to class tomorrow, how sure am I? I can fall ill. School may declare a holiday because of Bharat Bandh. There can of course be lockdown. Okay, there are so many other things. Okay, so what I should actually be saying is I will probably come to class tomorrow. What does probably mean? Am I coming or not? See, it means among all other options, most probably what will happen is that I will come to the class. So what are the other options? Other options are I may fall ill, there might be Bharat Bandh, or there might be lockdown. But considering all these other options, most likely is that I'm going to come to class. Why is it most probable? Because other options are less probable or less likely. Because how many times can there be Bharat Bandh? Not every day. And how many times will I fall ill, right? So they're less probable. But we are math students. Just more or less is not enough. We need numbers, correct? So how do we come to a number? So if I tell I'm going to come to class, let you want me to ask how much out of 100, maybe how much percent sure am I that I'll come to class? That we want to know. So that's what we will study in this chapter, how to arrive at a number that will tell us how much probable an event is. Okay, this probability actually helps us in various things. Okay, it is there in each and every aspect of our life. If I want to give you an example, if you go to a vegetable vendor and you ask for 1 kg of potato, then they will use this kind of a balance and they will give you 1 kg of potato. But will that be exact? What is the probability that this will be exactly 1 kg? It is no, maybe it's not exactly. It is probably plus or minus 15 or 20 grams. It's okay. We don't care if it is plus or minus that much. But if we go to a gold shop, okay, there can we accept this sort of a weighing machine? No, because there each and every gram matters. Each gram of gold is very costly. So here we will need a weighing machine which gives the exact weight, where the probability of error is much less. Correct, here the probability of error can be more. It's okay, it's acceptable. But here the probability of error should be very less. So based on what kind of probability of error is required, different places, different instruments are used. And similarly, there are a lot of decisions in life that we base on probabilities. For example, weather forecast. Weather forecast is a huge decision that is taken based on probabilities only. So probability is a very used thing in the world, and it is a very interesting topic to study. So now we were discussing about me coming to the class, right? So me coming to the class, we want to determine a number which will tell us how much probable it is that I will come to class. So let us say we take example of 100 classes. So what we want to determine the probability that I will come to class. So to see that, what we are going to do is we are going to look back at 100 classes, okay, in which I was supposed to come. Okay, then we will see that out of those 10 classes, I couldn't come because I was sick. On 5 of those classes, there was Bharat Bandh. 20 of those we had lockdown, and remaining 65 classes I was able to come and take class. So we have gotten this data now. Based on this, we want to calculate the probability that I will come to class. In ninth standard, you have learned something called experimental probability. What is that? If we consider this as an experiment, that is, me coming to class is an experiment. So what are the outcomes of that experiment? I can come to class or I cannot come to class. So now what you have done is, each day I come to class, you noted down whether I have come to the class or not. So based on whatever happened, you have noted it down. Now total number of classes is 100. So total number of trials that we have done for the experiment is 100. The number of classes in which I have come is 65. So the probability of me coming to class will become 65 divided by 100, because you have learnt experiment probability, that is number of trials in which the event happened divided by total number of trials. So here total number of trials is 100, because the experiment of that is me coming to class, that we have repeated 100 times, and then the event that we are looking for is when I come to the class. So number of times the event happened is 65 times. Number of times the experiment was done is 100 times. So 65 by 100 will be the probability of this event, that is me coming to class. So now we got some number. So now what we can tell is 65% of the time, or 0.65 is the probability that I will come to class. So this is what we have learned up to 9th standard. Now we want to see what we can do with this for several other experiments. Okay, let us consider a similar experiment with a coin. Let us ask two students to toss a coin 5 times and tell us what is the experimental probability of heads and tails. Okay, when we toss a coin, only two things can happen, that is heads or tails. Let us determine, we want to see, do we get more number of heads or no more number of tails. Okay, because we want to see which is more probable. So we have asked Akshat and Amrita to toss a coin 5 times. Akshat got 3 times heads, 2 times tails. Amrita got tails 4 times and head only 1 time. This is so when Akshat we ask, he tells that heads are coming more often, and when Amrita we ask, she will tell us that tails are coming more often. Now, who do we believe? Who is correct? So, according to Akshat, P of probability of heads is 3 by 5. How did this come? What is experimental probability? It is total number, it is the number of trials in which the event took place by total number of trials. What is the event here? Event is getting heads. How many times heads came? 3. Total number of trials is how much? 5. So probability that we will get heads is 3 by 5. Probability that we'll get tails, event of getting tails has happened 2 times. So 2 divided by total number of trials is 5. Okay, similarly, Amrita will show us these probabilities. Both of them got different. So who is correct? According to their experiments, both of them are correct. But what is wrong here? Like, we wanted an answer so that we will be able to determine whether heads will come more or tails will come more. We wanted to know the probability, but both of them have given different answers. What should we do now? If we think about this carefully, we can understand that throwing a coin only 5 times is not enough to determine the probability of heads and tails. So for example, this guy tossed it 5 times. Now, if he would have tossed it once more, then maybe tails would have come. Then the probability would have changed. Then he would have said probability of heads and tails will be equal, because 3 heads and 3 tails he would have gotten. Correct? Then again, if he would have tossed maybe something else. So tossing it only 5 times is not sufficient to give exact probability. Okay. So what should we do is the question. So what we did was we did experimental probability. So we performed an experiment and then we calculated the experimental probability. What is the problem with that is we don't know how many times to repeat the experiment to get the exact answer. So this is the main problem with experimental probability. So now we are going to look at this in another way. Instead of performing experiment, can we think about it in some other way so that we can get the probability of heads and tails? Let us see. We know that coin has only two sides. So whenever we toss the coin, only one of the side can come. So the outcomes of this experiment, that is tossing a coin, can be only heads or tails. We write it like this. we write it in flower brackets like this, and we write it as we will write all the outcomes of the experiment inside these brackets. So first out, what is the first outcome that is possible? Heads. Another outcome is tails. So two outcomes are possible. Now, how to calculate probability of heads or tails without experiment? Now let us see. This is where theoretical probability comes. What is theoretical probability? Means theoretical probability of an event E will be defined as number of outcomes favorable to E divided by number of possible outcomes of the experiment. So we will look at several examples to show this. Okay, number of outcomes favorable to E. Here, number of outcomes favorable to E we need, means E is getting heads, and number of total possible outcomes. What is the total number of possible outcomes? Heads and tails. So two outcomes. Let us see. All possible outcomes of the experiments are what? Let me write it here. For the only two outcomes are there, heads and tails. Okay, only two outcomes are possible. Now event 1, we want to see how what is the probability of getting a head. Event 1 is getting a head. Out of all these outcomes, now we are going to write favorable outcomes in this bracket. In this, which what happens means it is favorable. If H comes, that is a favorable outcome for this event. ಇದನ್ನ ಇನ್ನೊಂದ್ಸಲಿ ಹೇಳ್ತೀನಿ. ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದಾಗ ಏನೇನ್ ಆಗುತ್ತೋ, ಏನೇನ್ ಆಗಕ್ ಸಾಧ್ಯನೋ ಅದನ್ನ ನಾವು ಈ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಬರಿತೀವಿ. ಅದು ಆಲ್ ಔಟ್ಕಮ್ಸ್ ಆಫ್ ದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. ಸೊ ಕಾಯಿನ್ ಟಾಸ್ ಮಾಡೋದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಂತ ಅನ್ಕೊಂಡ್ರೆ, ಆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಇಂದ ನಮ್ಗೆ ಏನೇನ್ ಆಗಕ್ ಸಾಧ್ಯ, ಹೆಡ್ಸ್ ಬರ್ಬೋದು ಇಲ್ಲ ಟೇಲ್ಸ್ ಬರ್ಬೋದು. ಸೊ ಏನೇನ್ ಆಗಕ್ ಸಾಧ್ಯನೋ ಅದೆಲ್ಲ ಇಲ್ಲಿ ಬರಿತೀವಿ. ಇವಾಗ ಯಾವ್ದಾದ್ರು ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ, ಯಾವ್ದಾದ್ರು ಇವೆಂಟ್ ಪ್ರಾಬಬಿಲಿಟಿ ಕೇಳಿದಾಗ ಇವೆಂಟ್ ಗೆಟಿಂಗ್ ಅ ಹೆಡ್. ಸೊ ನಾವು ಫೇವರಬಲ್ ಔಟ್ಕಮ್ಸ್ ಈಕ್ವಲ್ ಟು ಅಂತ ಹಾಕ್ಬಿಟ್ಟು ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಏನ್ ಬರಿತೀವಿ, ಇಲ್ಲಿ ಏನೇನ್ ಇದೆಯೋ ಅಲ್ಲಿಂದ ಫಸ್ಟ್ ನೋಡ್ತೀವಿ, ಹೆಚ್ ತಗೋತೀವಿ. ಹೆಚ್ಚನ್ ಇಲ್ಲಿ ಹಾಕೋಣ. ಇದು ಮ್ಯಾಚ್ ಆಗುತ್ತಾ? ಗೆಟಿಂಗ್ ಅ ಹೆಡ್ಗೆ ಹೆಚ್ ಮ್ಯಾಚ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಈಸ್ ಓಕೆ. ಟೇಲ್ಸ್ ನೋ, event is getting ahead, so tails is not a favorable outcome. So how many favorable outcomes we got? Only one. So probability of this event of getting ahead will be number of outcomes favorable to E. ಎಷ್ಟು ಬಂತು? 1 divided by total number of all possible outcomes of the experiment. All possible outcomes of the experiment is 2. So probability will be 1/2. Getting a tail, ಏನ್ ಪಾಸಿಬಿಲಿಟಿ ಇರ್ಬೋದು? ಫೇವರಬಲ್ ಔಟ್ಕಮ್ಸ್ ಬರೆಯೋಣ. ಇದಕ್ಕೆ ಇದರಿಂದ ಒಂದೊಂದಾಗಿ ಹಾಕ್ಬೇಕು ನಾವು. ಹೆಡ್ಸ್ ಹಾಕಕ್ಕಾಗತ್ತಾ? ಇಲ್ಲಿ ಗೆಟಿಂಗ್ ಅ ಟೇಲ್ ಆಗಲ್ಲ. ಟೇಲ್ಸ್ ಹಾಕಕ್ಕಾಗತ್ತಾ? ಹಾಕಕ್ಕಾಗತ್ತೆ. ಓಕೆ, ವೆರಿ ಗುಡ್. ಟೇಲ್ಸ್ ಹಾಕೋಣ. ಇನ್ನೇನು ಮಿಕ್ಕಿಲ್ಲ, ಅಷ್ಟೇ ಮುಗೀತು. ಇವಾಗ ಎಷ್ಟು ಬಂತು? ಇದು ನಂಬರ್ ಆಫ್ ಫೇವರಬಲ್ ಔಟ್ಕಮ್ಸ್ ಈಕ್ವಲ್ ಟು 1. ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ event of getting a tail will be 1/2. Okay, so ಇವಾಗ ಇದು ಹೆಡ್ಸ್, ಇದು ಟೇಲ್ಸ್ ಗೊತ್ತಲ್ವಾ ನಿಮ್ಗೆ ಕಾಯಿನ್ ಅಲ್ಲಿ. ಇವಾಗ ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ನೋಡೋಣ, ಘೋಸ್ಟ್. ಸೊ ಕಾಯಿನ್ಸ್ ಇವೆಂಟ್, ಇವಾಗ ಇವೆಂಟ್ 1 ಇವೆಂಟ್ 2 ಏನಿತ್ತು? ಇವೆಂಟ್ 1 ಗೆಟಿಂಗ್ ಎ ಹೆಡ್, event 2 getting a tail, event 3 we are going to see the probability that coin suddenly becomes a ghost. What is the favorable outcomes? ಇಲ್ಲಿ ಹೆಡ್ಸ್ ಹಾಕಕ್ಕಾಗತ್ತಾ? ಇಲ್ಲ, ಬಿಕಾಸ್ ಘೋಸ್ಟ್ ಆಗ್ಬೇಕು ಅಂತ ಹೇಳ್ತಾ ಇದೆ. ಟೇಲ್ಸ್ ಹಾಕಕ್ಕಾಗತ್ತಾ? ಹಾಕಕ್ಕಾಗಲ್ಲ. ಸೊ ಘೋಸ್ಟ್ ಆಗ್ಬೇಕು ಅಂತ ಹೇಳ್ತದೆ. ಸೊ ನಮಗೆ ಫೇವರಬಲ್ ಔಟ್ಕಮ್ಸ್ ಅಲ್ಲಿ ಇದರಿಂದ ಏನನ್ನು ಹಾಕಕ್ಕಾಗಲ್ಲ. ಸೊ ವಿ ವಿಲ್ ಲೀವ್ ಇಟ್ ಎಂಪ್ಟಿ. ಸೊ ವಾಟ್ ಆರ್ ದ ನಂಬರ್ ಆಫ್ ಫೇವರಬಲ್ ಔಟ್ಕಮ್ಸ್? we will get favorable outcomes nothing. So number of favorable outcomes will be 0. So probability of this event will be 0 divided by all possible outcomes divided by 2. equal to 0. ಓಕೆ, ಸೊ ಇವಾಗ ಇದು ಥಿಯರಿಟಿಕಲ್ ಪ್ರಾಬಬಿಲಿಟಿ ಅಂತ. ಯಾಕೆ ಇವಾಗ ನಾವು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ನಾವು ಮಾಡ್ತಾನೆ ಇಲ್ಲ ಅಲ್ವಾ, ವಿ ಆರ್ ನಾಟ್ ಕಂಡಕ್ಟಿಂಗ್ ದ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಟ್ ಆಲ್. ವಾಟ್ ವಿ ಆರ್ ಡೂಯಿಂಗ್ ಇಸ್ we are thinking about it before only. We know that what are the outcomes of the experiment. We are going to write down all the outcomes of the experiment here, and then whichever is the favorable outcome we'll write it here. Then we will apply the formula, that is number of outcomes favorable to E divided by total number of outcomes. This will give us exact probability. Okay, ಈ ತರ ನೀನು ಅಮೃತಂಗ್ ಕೊಡು, ಅಕ್ಷತೆ ಕೊಡು, ಯಾವುದೇ ಸ್ಟೂಡೆಂಟಿಗೆ ಕೊಟ್ರು ಸೇಮ್ ಆನ್ಸರ್ ಬರುತ್ತೆ. ಸೊ ಅವನ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅನ್ನ ಎಷ್ಟಲ್ಲಿ ಮಾಡಬೇಕು ಅನ್ನೋ ಕನ್ಫ್ಯೂಷನ್ ಇರಲ್ಲ, ಬೇಗ ಆಗತ್ತೆ. ಸೊ ಇವಾಗ ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ನೋಡೋಣ. ಸೊ ಡೈಸ್ ರೋಲ್ ನೋಡೋಣ. ಇವಾಗ ಡೈಸ್ ಗೊತ್ತಲ್ವಾ, ಡೈಸ್ ಅಂತಂದ್ರೆ ಏನು, ಅದಕ್ಕೆ ಸ್ನೇಕ್ ಅಂಡ್ ಲ್ಯಾಡರ್ಗೆಲ್ಲ ಯೂಸ್ ಮಾಡೋದು. ಹೌ ಮೆನಿ ಫೇಸಸ್ ಆರ್ ದೇರ್ ಫಾರ್ ಅ ಡೈಸ್? 6. ಸೊ ವಿ ಕ್ಯಾನ್ ಗೆಟ್ 1 2 3 4 5 6 in the dice. So what the experiment is rolling the dice. When you roll the dice, what are the possible outcomes? 1 2 3 4 5 6 ಬರೆಯೋಣ. ಅದನ್ನ ಇಲ್ಲಿ ಎಲ್ಲ ಬರೆಯೋಣ. 1 2 3 5 6. ಓಕೆ, ಇವಾಗ ಮತ್ತೆ ಆ ಥರನೇ ಟ್ರೈ ಮಾಡೋಣ. event is getting a 1. So we want to calculate the probability of getting a 1. So now again from these all the possibilities of the experiment we will start writing favorable outcomes. 1 ಹಾಕಿದ್ರೆ ಆಗುತ್ತಾ? ಆಗುತ್ತೆ. 2 ಗೆಟಿಂಗ್ ಅ 1 ಆಗಲ್ಲ. ಇನ್ಯಾವುದೂ ಗೆಟಿಂಗ್ ಅ 1 ಬರೆಯೋಕೆ ಆಗಲ್ಲ. ಸೊ ಎಷ್ಟು ಬಂತು ನಮಗೆ ಇಲ್ಲಿ? ನಂಬರ್ ಆಫ್ ಫೇವರಬಲ್ ಔಟ್ಕಮ್ಸ್ 1. ಸೊ ಇವಾಗ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ದಿಸ್ ಇವೆಂಟ್ ಏನಾಗುತ್ತೆ? ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಫೇವರಬಲ್ ಔಟ್ಕಮ್ಸ್, ಇಟ್ ಇಸ್ 1 divided by number of all possible outcomes, that is all possible outcomes is 6 outcomes ಇದೆ. ಸೊ 6 ಅಂದ್ರೆ ಈ ನಂಬರ್ ಅಲ್ಲ, ಎಷ್ಟು ಔಟ್ಕಮ್ಸ್ ಇದೆ ಅಂತ ಕೌಂಟ್ ಮಾಡಬೇಕು. ಎಷ್ಟು? 1 2 3 4 5 6 ಟೋಟಲ್ 6 ಔಟ್ಕಮ್ಸ್ ಇದೆ ಅಲ್ವಾ, ಅದರಿಂದ ಇಲ್ಲಿ 6. ನೆಕ್ಸ್ಟ್ ಗೆಟಿಂಗ್ ಎ 2 ಇಸ್ ದ ನೆಕ್ಸ್ಟ್ ಇವೆಂಟ್. ಇದಕ್ಕೆ ಫೇವರೇಬಲ್ ಔಟ್ಕಮ್ಸ್ ಬರೆಯೋಣವಾ? 1 ಹಾಕಕ್ಕಾಗುತ್ತಾ? ಇಲ್ಲಿ ಆಗಲ್ಲ, ಗೆಟಿಂಗ್ ಎ 2 ಹೇಳಿದಾರೆ ಅವರು. ಸೊ 2 ಹಾಕ್ಬೋದು. ಇನ್ನು 2 3 4 5 6 ಏನೂ ಹಾಕಕ್ಕಾಗಲ್ಲ, ಬಿಕಾಸ್ ಇವೆಂಟು ಗೆಟಿಂಗ್ ಎ 2 ಅಂತ. ಎಷ್ಟು ಬಂತು ನಮಗೆ ನಂಬರ್ ಆಫ್ ಫೇವರೇಬಲ್ ಔಟ್ಕಮ್ಸು? ಇಲ್ಲೂ ಒಂದೇ ಒಂದು. ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಇವೆಂಟ್ ಏನಾಗತ್ತೆ ಹಾಗಿದ್ರೆ? 1 number of favorable outcomes is 1 divided by total number of outcomes is 6. Okay, ಇವಾಗ ಇನ್ನೊಂದು ನೋಡೋಣ. ವಾಟ್ ಇಸ್ ದ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಗೆಟಿಂಗ್ ಅನ್ ಈವನ್ ನಂಬರ್ ಅಲ್ವಾ? ಇವಾಗ ಮತ್ತೆ ಸೇಮ್ ಫೇವರೇಬಲ್ ಔಟ್ಕಮ್ಸ್ ಅನ್ನ ಇಲ್ಲಿ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ ಬರೆಯೋಣ. 1 ಹಾಕಕ್ಕಾಗತ್ತಾ? ಗೆಟಿಂಗ್ ಅನ್ ಈವನ್ ನಂಬರ್ ಹೇಳಿದ್ದಾರೆ. 1 ಈವನ್ ಅಲ್ಲ, ಹಾಕಕ್ಕಾಗಲ್ಲ. 2 ಹಾಕಕ್ಕಾಗತ್ತಾ? ಹಾಕ್ಬೋದು. ನೆಕ್ಸ್ಟ್ 3 ಹಾಕಕ್ಕಾಗತ್ತಾ? ಆಗಲ್ಲ. 4 ಆಗಲ್ಲ, ಆಗತ್ತೆ. 4 is even number, so 4 we can put. 5 we can't put. 6 we can. So 2 4 6 are the favorable outcomes. ಎಷ್ಟು ಬಂತು favorable outcomes? So we can get 3 favorable outcomes. So probability of the event will become number of favorable outcomes, that is 3 ಆಯ್ತಾ, divided by total number of all possible outcomes, that will be 6. ಗೊತ್ತಾಯ್ತಲ್ವಾ? ಹಾಗಿದ್ರೆ ಏನಾಗುತ್ತೆ ಇದು? This will become 1/2. ಓಕೆ, ಇವಾಗ ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ನೋಡೋಣ ಆಯ್ತಾ, ಕ್ಲಿಯರ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಸೊ ಇವಾಗ ನೆಕ್ಸ್ಟ್ ಗೆಟಿಂಗ್ ಅನ್ ಆಡ್ ನಂಬರ್. ಫೇವರಬಲ್ ಔಟ್ಕಮ್ಸ್ ಮತ್ತೆ ಬರೆಯಕ್ಕೆ ಶುರು ಮಾಡೋಣ. 1 ಹಾಕಕ್ಕಾಗತ್ತಾ? ಆಗತ್ತೆ. ನೆಕ್ಸ್ಟ್ 2 ಆಗಲ್ಲ, 3 ಆಗತ್ತೆ. 4 ಆಗಲ್ಲ, 5 ಆಗತ್ತೆ. 6 ಆಗಲ್ಲ. ಸೊ ಇವಾಗ ನಮಗೆ 1 3 5 3 ಸಿಕ್ತು. ಸೊ ನಂಬರ್ ಆಫ್ ಫೇವರೇಬಲ್ ಔಟ್ಕಮ್ಸ್ ಎಷ್ಟಾಯ್ತು? 3. ಸೊ ಇವಾಗ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಇವೆಂಟ್ ಏನಾಗುತ್ತೆ? ನಂಬರ್ ಆಫ್ ಫೇವರೇಬಲ್ ಔಟ್ಕಮ್ಸ್ ದಟ್ ಇಸ್ 3. ಓಕೆ, 3 divided by all possible outcomes is 6. Same as is equal to 1/2. ಸೊ ಇವಾಗ ಗೆಟಿಂಗ್ ಅ ಪ್ರೈಮ್ ನಂಬರ್ ಫೇವರೇಬಲ್ ಔಟ್ಕಮ್ಸ್ ಬರೆಯೋಣ. ಇದಕ್ಕೆ ಏನಾಗುತ್ತೆ? 1 ಹಾಕ್ಬೋದಾ? ಹಾಕ್ಬೋದು, ಯಾಕೆಂದ್ರೆ 1 ಇಸ್ ಅ ಪ್ರೈಮ್ ನಂಬರ್. 2 ಹಾಕ್ಬೋದಾ? ಹಾಕ್ಬೋದು, ಯಾಕಂದ್ರೆ 2 ಇಸ್ ಆಲ್ಸೋ ಅ ಪ್ರೈಮ್ ನಂಬರ್. 3 is also a prime number, ಹಾಕ್ಬೋದು. 4 ಹಾಕ್ಬೋದಾ? 4 ಹಾಕಕ್ಕಾಗಲ್ಲ, ಬಿಕಾಸ್ 4 is not a prime number. 5 ಹಾಕ್ಬೋದು. ಸೊ ಎಷ್ಟಾಯ್ತು ನಮಗೆ ಫೇವರೇಬಲ್ ಔಟ್ಕಮ್ಸು? ಈಕ್ವಲ್ ಟು 4 ಆಯ್ತು. ನಮಗೆ 4 ಫೇವರೇಬಲ್ ಔಟ್ಕಮ್ಸ್ ಬಂತು. ಸೊ ಪ್ರಾಬಬಿಲಿಟಿ ಏನಾಗುತ್ತೆ? ನಂಬರ್ ಆಫ್ ಫೇವರೇಬಲ್ ಔಟ್ಕಮ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಟೋಟಲ್ ನಂಬರ್ ಆಫ್ ಔಟ್ಕಮ್ಸ್ 6 ಈಕ್ವಲ್ ಟು 2/3. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇವೆಂಟ್ ಇಸ್ ಗೆಟಿಂಗ್ ಅ ನಂಬರ್ ಅಬೌಟ್ 20. ಏನಾದ್ರು ಹಾಕ್ಬೋದಾ? ಇವಾಗ ಇದರಲ್ಲಿ ಬ್ರಾಕೆಟ್ ಅಲ್ಲಿ 1 ಹಾಕ್ಬೋದಾ? ಇಲ್ಲ. 2 ಹಾಕ್ಬೋದಾ? ಇಲ್ಲ. 3 4 5 6 ಏನು ಹಾಕಕ್ಕಾಗಲ್ಲ ಬ್ರಾಕೆಟ್, ಬಿಕಾಸ್ ಯಾವುದು ಅಬೌಟ್ 20 ಇಲ್ಲ. ಸೊ ಇದು ಎಂಟಿ ಸೆಟ್ ಆಗುತ್ತೆ. ಸೊ ಇವಾಗ ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಔಟ್ಕಮ್ಸು? 0. ಪ್ರಾಬಬಿಲಿಟಿ ಏನಾಗುತ್ತೆ? 0/6 ಈಕ್ವಲ್ ಟು 0. ಓಕೆ, ಇದು ಡೈಸ್ ರೋಲ್ ಎಕ್ಸಾಂಪಲ್ದು. Now let us move on to the next example that I'm going to take, that is deck of cards. If you have played cards, then you should be able to easily relate to it. Let me explain easily. Okay, in cards there are 4 types of cards. Okay, there will be 13 spade shaped cards, 13 clover or flower shaped cards, 13 heart shaped cards, and 13 diamond cards. Okay, so how many? These are 26 black cards, and here there are 26 red cards. Okay, so totally in a deck of cards there will be 52 cards. So what are the 52 cards? I have told you there will be 13 clover, 13 spade, 13 heart, and 13 diamonds. Now in 13 means what are all the 13? Ace is considered as 1. This A is, we pronounce it as ace. Okay, this is considered as 1. So ace 2 3 4 5 6 7 8 9 10, J Q K. Okay, jack, queen, and king. So these are the cards. So in each shape there will be all these 13 cards, and totally it will become 13 plus 13 plus 13 plus 13 is equal to 52. So these are the deck of cards. Now based on these we will do an experiment. What is the experiment? Picking one card from the deck of the cards is the experiment. What are the possible outcomes of this experiment? One card, if you are picking from the deck of cards, it can be any card, right? So it can be, what is that? Heart ace, heart ace, okay, heart 1, okay, then heart 2, heart 3, heart 4, heart 4, heart 5, heart 6, then up to heart king. Then same thing with spade, right? Spade A, spade 1, spade 2, spade 3, it can be. Then similarly, so finally we will get 52 possible cards. So if we pick one card at random from the card, which means we can get any of the any of these we can get, no, any of this card. So it can be what I started with heart A, no, heart A, heart 2, heart 3, and then it can be these, it can be these, anything. So finally totally here number of possible cases will be 52. So we have total number of possible outcomes of the experiment is 52. Now event 1, picking an ace. Favorable outcomes. What are the favorable outcomes? Let us see. Heart ace. Heart ace is an ace or not? Yes, it is an ace. So we can put heart ace in this one. Heart ace. Next, next we will try heart 1. Heart 1 is not an ace. Sorry, heart ace. This is heart 2. Heart ace. Heart 1, there is no such card as a heart 1. Heart 2, shall we put it here? We can't, because it is not an ace. Heart king is not an ace. Only ace is an ace. Okay, so only heart ace we were able to put. Then spade ace we can put. Correct? Spade ace we can put. Then we can put clover ace or flower ace. Then we can put uh, diamond ace. Diamond ace. Let us go back to our diagram and verify this. So how many aces are there? Four aces are there. Clover ace, spade ace, heart ace, and diamond ace. There are no other aces here. So we have put here. So picking ace, favorable outcomes will be heart ace, spade ace, clover ace, and diamond ace. Now, what is the number of favorable outcomes? 1, 2, 3, 4. 4. What is the probability? Total number of favorable outcomes. Okay, 4 divided by what is the all possible outcomes? 52. 52. Okay, next, getting a heart card. Number of what are the favorable outcomes of getting a heart? We can get a heart is, yes, we can put it here. We can put heart 2 because yes, that is also a heart card. So similarly, how much can we put? We can put heart ace, heart 2, heart 3, heart 4, heart 5. All these we can put in the set. No, apart from that we cannot put anything else because all these are heart cards. So we can put up to heart king, so on up to 2, 3, 4, up to so on up to heart king. How many it will become? Ace 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So 13. 13 is the number of favorable cases. So probability will be what? Number of favorable cases divided by number of all possible outcomes. Number of favorable cases is 13. All possible cases is 52. Okay, so this will be 13 ones are 13 fours are, so probability will become 1 by 4. Okay, so this is an example that I have taken to teach you about some examples with cards. Okay, so after these many examples you should have understood the theoretical probability. So what is the summary of this video is two things you should understand. What is experimental probability? In experimental probability, we conduct the experiments, we note down the results, and how many times we conducted the experiment, that is the total number of trials, that will be denominator. Numerator will be number of trials in which the event happened. So if for example we are taking uh, heads is the event happened, how many heads we got will be the numerator, how many times we toss the coin will be in the denominator. About me coming to the class, how many times we did the experiment will be in the denominator, how many times I came to the class will be in the numerator. Okay, no, theoretical probability is not like that. We don't perform any experiment. In theoretical probability, beforehand, we will decide what are all possible outcomes of the experiment. Just like how we decided for a dice, what are the all possible outcomes of throwing a dice? We can get any of the 6 spaces. There is no other option. So what we do is number of outcomes favorable. So whenever we choose an event, we will determine its probability based on number of outcomes favorable to event divided by number of all possible outcomes. How do we do this favorable? We draw the bracket, and from the bracket of all possible outcomes we pick one by one and see whether it matches with the event. If it does match, then we put it in the bracket. And then finally, how many our element is there in this bracket will be equal to the favorable outcomes. Okay, so that will be number of favorable outcomes divided by all possible outcomes of the experiment. Okay, so this is the summary that this video, by the end of this video you should be completely familiar with experimental probability, theoretical probability, what is the difference. Okay, if you are understanding this much, then we can end the video here. If you get any doubt, please ask me in the comments. Okay, bye.